you are going to experience some of the science that we do here at Pedmore High School. And I'm going to show you some magic tricks which are actually just science. So you will be able to know how the trick is done and the science behind it, and some of the tricks you can actually do at home. So I'm going to remove my robe because I don't want my flappy sleeves all over the place, and I'm going to show you the first experiment with electricity. So here we have a device called a Graaff Generator, and I can generate some mini lightning using the Graaff Generator. So if you have a look in here, this gap here, then so what we've got is some electrons that make our electricity jumping from one of the balls to the other. Now I can do something else with the Graaff, and that's to make objects float. So that's what I'm going to do next. How cool is that? Do we want to do it again? So this is something that we get to play with at Pedmore High School, and we get to play with electricity, and we learn about static electricity. So what was happening with this, the electrons were moving again from the ball into the metal cups, and because all of those electrons are oppositely charged, a bit like a magnet, they push each other apart. So each one of these would fly off of the top. So it's not magic, it's just science. We're going to use fire. And we're going to use one of these devices called a Bunsen burner. And again, I'm going to make some objects float. So what I've got in here is actually just some empty tea bags. If I can get them to stand up. And I'm going to set fire to them, and then they're going to float. Did you see that? Yeah. Brilliant. I'll do it again, just in case. Oh, maybe we'll do a bit better without the lights on. You'll see it a bit better. Cool? So that is just, they are just empty tea bags, like I said. So I've taken the tea bag out of them, some tea out of them, and unravelled them. And because when I set light to them, the air inside the tea bag is really, really hot. And that means that they become less dense. Now if you know what that means, then you're already a clever cookie. And what less dense means is the air particles get further apart and they become lighter and they lift up into the air. Just going to give it one more go. There we go. Perfect. So we're going to come back to the Bunsen burner in a moment. And we're going to do some colour changing techniques now. And I'm going to use milk. So this is actually one you can do at home, because I'm going to use milk, and I'm going to use food colouring, and I'm going to use washing up liquid. So the milk goes into a shallow dish. With a little bit of food colouring in the middle. Let's use a nice colour. I like blue. Let's do blue. And what I'm going to do is make the milk move around with the food colouring so that it dances. Might want to get a bit closer in this one. See how it moved? So let's put another colour in there. Make the red move with my finger in the milk. Let's do a different one in a different colour. So what's happening here is in the milk we've got fats and we've got water and proteins. Now, when the food colour is added, we can see the milk moving. That's why I add the food colouring. And then the soap attaches to the fat in the milk, which makes the food colouring move with the milk. And that's why we use soap to do our washing up. So it attaches to all the grease and the fat on our washing up, and it makes them clean. And you can do that one at home. You could add lots more colours in if you wanted to, so you could make it bigger and put 4 dots of food colouring in, and you just got to use soap. I'm going to give this a shake and it's going to change colour. You see that? It's gone from clear to blue, and I'm going to leave it and it will change back. And this contains something called methylene blue, which you might not have heard of before. So, and there's also got glucose in there. And glucose is a sugar, and the sugar and the methylene blue will react together and turns the blue clear. Now when I shake it, the methylene blue then reacts with oxygen in the air that's in the container and turns it back to blue, and then eventually this will turn back to colourless. So I'm just going to let that happen whilst I set up the next one. Universal indicator. It does take a moment to work that one, to turn back. But it's quite fun to do, so it's going now, you can see. It'll go back blue. So that's pretty cool, right? So that's something called methylene blue, that one. I'm going to do some more colour changing stuff. So, this time I've got 2 clear liquids. I'm going to add a green liquid to it. So, we've got a green liquid here. And I've added it to that one. Let's pour a little bit more in. And it's got a dark green. And then I'm going to add this other clear liquid to it, and we're going to watch to see what happens. And I've changed it to red. And I can change it back to green, and then yellow. Which one's that? I'm going to make it even more red using more of this clear liquid. Give it a little twirl, make sure it's going to stay red this time. So this time I'm using something called sodium hydroxide and hydrochloric acid. Now I bet you've heard of hydrochloric acid before, or at least heard of acids before. And when they are added to this green liquid, which is called universal indicator, they turn red. And sodium hydroxide is the opposite to an acid. It's an alkali. And when you add an alkali to universal indicator, it will go dark green, blue, or maybe even purple. But when you add an acid to an alkali together, you can start changing the different colours, and it looks pretty cool. I'm going to add some more of the alkali. See if I can get it back to go the other way. Pretty cool, right? You can do this when you come up to Pedmore. We get to play with acids and alkalis. It's great fun. So that's gone back to the green of the alkali. And when you mix an acid and an alkali together, you actually get water and salt. And it's the water that makes the universal indicator turn green when it goes green. Okay, and I'm going to do another one that you can actually do at home. Thank you. So we're going to mix some water and some oil and some food colouring together. So you've got all those things at home, you've got water, you've got oil, and you've got food colouring. And we're going to make a lava lamp. So this is going to dance around, because I'm going to use... No. Some food colouring, go into the water. And something called an Alka-Seltzer, which you might have heard of before. And this is going to dance and make a little lava lamp. Lava lamps are cool, right? I used to have a lava lamp when I was a kid. So you can do this at home. So the Alka-Seltzer is producing lots of carbon dioxide. Now if you know anything about carbon dioxide, it's the gas that we breathe out, and it is producing all these bubbles, attaching to the food colouring and the oil and making bubbles through the oil. Because oil and water don't mix, you see. We can see the layers of the oil in the water. But the Alka-Seltzer, whilst it's dissolving, producing all these bubbles, making the bubbles go through the lava lamp, through the oil making a lava lamp. So you could do that one at home. All you need is food colouring, oil, water and Alka-Seltzer, which you can buy at Tesco's. Thank you. So the next one, I'm going to make some toothpaste, but I'm going to make it extra large because I need it for my pet elephant. So I need to make some more toothpaste for him. So what I've got in here is some more soap. So I've got some more soap. I've got something called hydrogen peroxide. And I'm going to add potassium iodide to the mix. And hopefully I'll be able to get some toothpaste for my pet elephant. There we go. Can we see that? All those bubbles. So this one we can do at Pedmore as well. So you can't do this one at home, but we can do this one at Pedmore. So I've got some nice toothpaste for my elephant now. So what's happening here is the hydrogen peroxide that was in the tube was actually breaking down anyway into oxygen and water, but I've sped up that reaction with some potassium iodide, so that's the stuff I added afterwards. So I've got this explosion of oxygen bubbles now, creating lots and lots and lots of oxygen. You can actually see some steam coming off the top because it's a really hot reaction as well. So I'm going to have to let this cool down before I give it to my elephant to clean his teeth with. I think this again. Right, the next one I'm going to play with fire again. I'm pretty sure we like play with a little bit of fire. And I'm going to make a pop noise. And I mean, not a little pop. I'm aiming for a big pop. So I'm going to make some hydrogen using hydrochloric acid and magnesium. If you've ever heard of magnesium before, that is a metal, and when it reacts with acid, it produces hydrogen. So I'm collecting the hydrogen in this boiling tube here. You can see the reaction going on underneath. Can you see all those bubbles? I'm collecting all the hydrogen. And I want it to be loud, so I'm just going to wait. Make sure I've got loads and loads of hydrogen collected. Wow! Did you hear that?
Yeah.
That was loud, wasn't it? So I'm going to do it again because I love this one, it's fun. So I collect some more hydrogen. So I've said that the hydrogen is being produced, but hydrogen is explosive. It's really, really flammable. So when I light it and it reacts with oxygen in the air, it makes a little mini explosion in my hand. Just make sure I got enough. And you can, if you watch carefully, see the flames too. Hopefully it works again. Oh, not quite so loud that time, never mind. Brilliant, right. I'm still going to play with some more flames now. I'm going to make coloured flames this time. So, my favourite is this one.
Ooh.
Is that cool? Can you see that colour?
Yeah.
So that's copper. So you guys can do this. When you go up to Pedmore High School, you guys can do this. I can make some other colours. So let's do a red, shall we? Let's do a red this time. So we've got different metals and they all burn different colours because the electrons in them get excited by the flames and they all get excited by different amounts and that produces different colours. So that's lithium. The first one was copper, this one's lithium. Gorgeous red colour. Let's do potassium. Potassium has a lilac colour. So it's like a light purple pink. And we've got sodium. Sodium burns yellow. And then I've also got calcium. And calcium is an orangey reddy colour. I quite like mixing them together sometimes because it's fun. So if I do, let's do copper and potassium. So I've got pink and the green together. Let's see what that does. What if I do the green and the red? Let's do green and red, that's cool too. So multicoloured flames. She said? It's always a favourite, this one, isn't it? Shall I do the pink and the red? We'll do the pink and red, that's cool. Where's the pink one gone? I've run out of pink, there we go. So you'll be able to do this when you get to high school? Play with the different colours? I'm just burning sticks now. Let's do one more. We'll do the calcium again. That's the orange one. So we can identify different metals from the colours that they burn. And if I wanted to know what metal I got, I didn't know what it was, I could burn a little bit of it, I could figure it out this way. So those are cool. And I've made a real mess over here now. It's great. Right, the next one, next magic trick, I'm going to use heat and water to crush a can. Okay? Need lights, yeah, please. So I'm going to heat up the can to start with. And inside the can I put a little bit of water. And I'm just going to wait until that water starts to turn into steam. You know when you boil your kettle, you get steam out of the top. So I'm just waiting for that water to start turning into steam. And then obviously the water and the air that is in there is going to be really, really hot. That went well. Yeah, you grab it. So when the air in there is really, really hot, it's at a really low pressure, and I'm going to rapidly cool it down with the water that's in the bowl. And that means that the pressure increases really quickly, meaning the can will be crushed. Fingers crossed. Work that time. Right, we've got one more can that we can do it with, so we'll have one more go at it. Huh? Okay, great. So the can now got lots of water inside of it. You can see that it's been crushed. So like I said, the hot air that's inside, all that hot water, steam that's inside, that really low pressure. So when I cool it down, that pressure goes up really, really quickly and sucks the sides in of the can, meaning that it gets crushed. But I do have to get it right, otherwise it doesn't work like the first attempt. One more go. Whoa, that one went really well that time as well. Can you see that? Crush the can. Next one, I'm going to suck an egg into this tube. Now, the egg's not going to go in yet. See? That doesn't go in. But if I heat up this water and then let it cool, it will suck the egg in. So this is all about that pressure again that I mentioned earlier. So heating and cooling things creates lots and lots of pressure. So when I heat this up, the pressure's really low. Well then when I let it cool down again, the pressure will get high again and it will suck my egg into the tube. Turn the Bunsen burner off, put my egg on the top, and I'll watch. So that's not going to go in, right? That's not going to go anywhere. So as the water cools and the air inside cools down, it will start to suck the egg through. So you could do this at home if you've got a bottle. You heat it up, put some hot water from the kettle inside, have mum or dad or an adult to help you, boil an egg. Yeah, it is. It's stretching out, it's quite funny. Nice popping noise as well. Brilliant, right. Next bit I'm going to do with some water and static electricity. Now, if you've ever known anything with static electricity, you rub the balloon on your hair before and got it to stick up. That's all about static electricity. So what I'm going to do is use static electricity to bend water. So bending water from the tap. I'm going to get my tap running. And like you have to rub that balloon on your head to make your hair stand up, I have to rub this plastic with this cloth and I can bend the water. So this isn't science, this is magic. I rub it again, do it again. A bit better, that side. So it's those pesky electrons again. So I'm rubbing electrons onto the piece of plastic. And there are electrons and protons in the water. And those protons are oppositely charged to electrons. And they get attracted. So like when you stick two magnets together, they attract each other and stick together. So that's what these electrons and protons want to do. They want to stick together. So that makes the water bend towards my plastic stick. We're on to our last few tricks now. The next one, I'm going to make something disappear. I'm going to use something called glycerol. What's that one in it? To make this boiling tube disappear. Now let me show you what happens when I put this into this test tube. Disappears. It's gone, it's gone. See, I am magic really. Can you see it? It's gone. I'll put it back out. It's really still there, I promise. It's just gone. So if I show you what happens when I've got water, so with water, the same thing does not happen. So you can still see the boiling tube when it's in the water, but you can't see it when it's in the glycerol. So glycerol is a bit like oil, it's gloopy and sticky. But it has what you call the same refractive index as the glass. That means that it bends light by the same amount. So when you put the two things together, you can't see them. It turns the one invisible. And this is something we get to play with in year 11. So yeah, disappearing. So magic isn't magic really, it's just science. It's just really wrongly labelled. I'm going to do it, but I'm going to do it on here, on that side. Alright. Okay, the next bit, I'm going to come around this side and I'm going to snap a piece of wood with paper. Okay? So what I'm going to do is put the paper over the top of the wood and I'm going to karate chop it and I'm going to snap the wood. I haven't done this in a cabin before. Ta-da! So I can break wood with paper. How cool is that? Can we do it one more time? We have the other piece. Just in case.
You just demonstrate it's not pretend wood.
It's not pretend wood, I promise you. It's not pretend wood. I'm just super strong, that's all it is. So I'm going to karate chop it. All I've put over the top is paper. I promise there's nothing under there, it's just paper. So here we go. Didn't go flying off that time. Still here. So if you've got thin pieces of wood at home like that, you can do this with it. You have to have quite a big piece of paper. And what happens is, when I put a lot of force onto the wood with my hands, because I'm super strong, it creates a lot of pressure over the top of the paper. And that pressure comes from the air. Because lots of people think that air doesn't weigh anything, but air does weigh something. And you can feel the air if you wave your hand. You can feel it, so you know it's there. And it creates a lot of pressure on top of the paper, meaning that the wood that's under the paper stays there and it snaps in half, making you look super strong by breaking wood with paper. Right. That is actually the end of our magic show today. Those are all the tricks that I've got to show you today. Magic isn't magic really, it's just science. So everything can be explained using science. So if you have the knowledge and you can do these tricks yourselves, and I've shown you a couple of tricks you can do at home. And then if you come up to Pedmore, we do these with you all of the time. So you get to have great fun doing tricks like this all of the time. So, I've been Miss Smith, and I hope to see you all in September when you come up to see me.